Hey, this is Roland McPherson, Real Turf Tech, keeping it real. I've got the height of cut gauge calibration plate here. You will see another video on my YouTube channel, Roller Tamer channel. You'll see in the other video about height of cut gauges, what issues that we run into with those gauges. And this calibration plate was designed to address all of those issues. So it allows me to check and calibrate a height of cut gauge several different ways, quickly and accurately. It checks the gauge for flatness. It will calibrate the gauge whether it's flat or not. It measures the amount of deflection in hands-free mode, and it will show you if your catch is tapered enough for your cutting units. So I've got the same gauge here that was in my other video. I am going to check it for flatness by laying it down on this top surface of the plate is flat to within less than 1 mil. Remember, 1 mil is 1/1000th of an inch. So less than 1 mil over the entire top surface. So I've got it down. So I've got a 2 mil shim here that will not slip underneath any point. That tells me that this bar is pretty darn flat. It's better than most of the ones that I run into. Okay, even if this bar was not flat, I could still calibrate it. I just like to get a general idea of how flat or not flat it is. Okay, I've marked where this bar touches the front and rear rollers of my greens cutting units. I'm going to slip a 10 mil shim under each mark, and this simulates that the gauge is pressing up against the front and rear rollers. Then I'm going to slip the catch underneath the lip. The lip of the plate on this side is bottom side is parallel to the top. On the bottom side of the lip over here on the left side, it's not, it's tapered. We'll discuss that a little bit later. So I'm gonna simulate checking the height of cut, and I know the thickness of that lip is 100 mil. The thickness of these shims are 10, so I've got a height of cut of 110 determined by 3 points. These 2 points and the edge of that lip, which simulates the cutting point of a bed knife. Okay, so this gauge has already been calibrated. If it was not reading 110, then I would calibrate it to read 110. Now, as I discussed in the other video, it's important to have a tapered underside of the catch, and that taper angle should be greater than the top face angle of your bed knife, shown here, both when the bed knife is new or freshly ground, whenever that knife is installed, and also when that bed knife is spent at the end of its service. that angle, if it starts out, as you'll see in the other video, if it starts out at 2 degrees or 9 degrees, that angle is going to increase. So this taper under here needs to be greater than the angle of that top face when the bed knife is at the end of its life cycle. So here on this side, I've got an angle of 8 degrees, simulating the top face of a bed knife that's 8 degrees, or negative 8 degrees, depending on how you look at it. So I'm going to turn this gauge around and measure the height of cut. When the bed knife top face angle is 8 degrees. And I'm still getting 110. That tells me that the taper of the catch is sufficient for my cutting unit. Okay, now we're going to measure deflection. I'm going to put the magnet back on. And I'm going to use this gauge. I'm going to let the magnet hold it up to the cutting unit, so to speak. And with this plate, I can measure how much deflection I'm getting due to the magnet, or whatever hands-free mechanism that you have. Reading about 108, so that tells me that this magnet is pulling this bar down, so it's reading 2 mil less than the actual height of cut. That's fine as long as I know that, and I'm using it in hands-free mode, so I'm not pushing on it and causing greater deflection. As long as I know what the deflection is when it's in hands-free mode, that's fine. I can either calibrate it like that to read 110 when it's deflected, or I can just adjust my height to 108 if I wanted my height to be 110.